welcome back to my class. In the series of learning data structures through C, in the previous video we discussed about the array data structure. So we learned how we can use arrays in data structure, that is the first linear data structure. So we discussed about what is array, the declaration of array, initialization of array and the memory representation of array. Well, in today's video, we will discuss about the operations that what we can perform on arrays data structure. So we already discussed about the operations on the non-primitive data structure. So array also comes under non-primitive. Under non-primitive, it comes under linear data structure. So when we say linear data structure, the operations that what we perform on linear data structure are the same. So we have discussed about these operations also: traversal, insertion, deletion, searching, sorting and merging. And all the definitions of these operations is also being discussed. Please do check out the playlist. In today's video, we will discuss about the operation called traversal. And all these operations will be dealt separately in separate videos one by one with algorithm, program and execution. So those who are new to my channel, please subscribe to my channel and click on the bell icon so that you can get the notification of all the new videos. Watch the video till the end. Do not skip the video. And if you like the video, please click on the like button and share the video to all your friends. So here we have the operations. The operations that what we can perform on array data structure is same as the operations that what we perform on the non-primitive data structure, that is linear data structure. So under non-primitive we have linear. So we have two types of data structure. One is primitive data structure and the other one is non-primitive data structure. So we have two types of data structure, non-primitive and primitive. So under non-primitive we have the linear data structure and we have non-linear data structure. So under linear data structure we have arrays, stacks, queues, linked list, all those things. And in non-linear we have trees and the graph. So all these things we have discussed already. And in primitive we have all the fundamental type: integer, then we have float, we have double, then we have the character data type. All these are primitive. Basic. Primitive means basic data type and non-primitive means complex data type. So under complex data type, we discussed about the primitive operations, data structure operations and also about the non-primitive data structure operations. Under non-primitive, we discussed all these operations. So non-primitive means here under non-primitive we have linear, under linear we are discussing arrays. So if you get some Viva questions, you can answer like what are all the operations for non-primitive or what are all the operations for linear, or it could be like what are all the operations on arrays that what we can perform means you can say the traversal, insertion, deletion, searching, sorting and merging. So operations performed on non-primitive, operations performed on linear data structure, or it could be operations performed on arrays. This is what the answer: traversal, insertion, deletion, searching and sorting. So we will study about the traversal, algorithm and program. Traversal. So what is traversal? Traversal means accessing each element of the array. So we have the array. We try to access each element of the array exactly once so that we can perform some or the other operations. Why we need to do these traversal? So why we need to visit each and every element of the array? See, when I say I want to perform some operations on the array, say for example, I want to search for a particular element in the array. So I want to find the element 40. So I need to get the position of that element. So what I need to do? I need to search for that element, in the sense I have to traverse into the array. I have to travel into the array. I have to visit each and every element of the array present right from the index 0 up to n minus 1. So this is the array which is storing 5 elements. Say for example, the size of n is 5. Maximum 5 elements I am storing here. The limit that what I have given is just for an example 5. So I need to visit the array elements, means I have to start from the index value 0. See, always the index starts from 0. From the index 0 up to 4 means it is n minus 1. N is 5. 5 minus 1, that is equal to 4. I need to travel each and every element. I need to check whether that search element is available in the array or not. So I am performing that operation. So we have to perform one or the other operations. In order to perform that, we need to travel into the array. That is what traversal. Right. So here is the algorithm to understand the traversal. So what we need to do, when I say I need to visit each and every array element, I need to start from the beginning of the element. So I can also call this 0 as lower bound. What do we call it as? It is lower bound. So lower bound is always 0. And this n minus 1 value, which is n minus 1, we call this as upper bound. It is upper bound. Lower bound and upper bound. Upper bound is always n minus 1. So we need to get into the array, means I need to put some loop here. Of course, you should know about the for loop. Any doubt you have with for loop, you can please check out the playlist of C language. C programming language. Under the playlist of C, you can get the content of for loop. So we need to start from 0 and we need to travel up to n minus 1. So what we do, the first step of the algorithm says you get into the array from the index value 0 up to n minus 1. From 0 to n minus 1 I need to traverse. So I need to check whether I am within the bound of 0 to 4. If I am within the bound of 0 to 4, then I should get inside the loop. I need to have some loop. I need to get inside the loop and I need to process that. So process depends on the operation that what we are going to perform. I may search for element. I may find the maximum of the element, minimum of the array elements, like this. Any operation it can be. That is what process. So for example, I start from the index value 0. When I start from the index value 0, I need to access this element a of 0. I think you all know these index values. A of 0. A is the array name. So in the algorithm, we need to write the assumption A is the array name. A is the array name and n is the limit of the array. Say for example, I can take some example. The limit is 5. And when I say LOC is the location. See, algorithm is nothing but the step-by-step procedure or step-by-step instructions that what we write to solve a given problem. That is what algorithm. It is well-defined procedural steps to solve a given problem. See, here I need to do the traversal. And how do I do the traversal? How do I visit each and every element of the array? I need to start from the index value 0 and I have to just move on one by one up to n minus 1. Of course, the elements will be in a linear fashion. The elements will be arranged one after the other. In the arrays, we have consecutive memory locations. See the address 101 to 2 bytes, 101, 102, 103, 104, 105, 106, 107, 108, 109, 110. So for example, I have the integer array. Let me take 16-bit machine, say 2 bytes. I can also take 32-bit machine. I have just taken 16-bit machine just for the example. So it is 2 bytes memory allocation. Each element requires 2 bytes. So it is 101, 102, 2 bytes. If I just say what is the address of A of 0, it is 101. We need to say only 101. What is the address of A of 1? 103. A of 2, 105. A of 3, 107. A of 4, 109. Right? So here we have 10, 20, 30, 40 and 50. The elements that what I have stored in this array. So I need to start the loop beginning from the 0 and I need to traverse up to n minus 1. I need to check whether I am within the bound of 0 to n minus 1. If it is true, then process that a of location. Location means 0. A of 0. A of 0 means 10. I need to process this. After I process this, I need to move to the next element. So I need to get back to the loop. Loop iterates. I need to check 1 to n minus 1. If it is true, once again process a of it is 1. Again look back a of 2, a of 3 and a of 4. In every iteration we check whether we are within the bound of array. If it is true, then I process it. So like this I traverse every element a of 1, 2, 3 and 4. How this loop goes, that you can understand in the program in a still better way. So once the loop is done, once I reach n minus 1, there is nothing to traverse, then it is end of the for loop. Then step 2, it says exit. This is the algorithm. So we should know how to use the for loop. The for loop process you should know. So for loop starts from 0. I'll iterate, I'll go to next location. I'll iterate, iteration means I'm going to go to the next location. When I reach to the end position, the loop terminates. It means I have traversed everything. So let us see an example program for this. So here we go with the complete program, and this program is a very simple program where I am trying to find the frequency of the given element. See, this is what the array elements we have stored. Say we have 5 elements 10, 30, 70, 40 and 20. And I just want to find the frequency of a given element. Say I just want to find the frequency of 70. Frequency means the occurrence of the element. How many times the element occurred in the array. So what I need to do, I need to take that element, the element for which I need to find the frequency. I need to compare that with every element of the array. So for example, I'll take 70. I need to compare with 10. If it is equal to 10, then the frequency count get increases. If not, it remains 0. Compare that with 30. No, it is not matching. So frequency will not be increased. Compare that with 70. Yes, 70 is equal to 70. Then the frequency count gets increased. Again, check with 40. No. Again, check with 20. No. So here what happens? I am doing the traversal. In the process of traversal, I am finding the frequency of a particular element. So for example, if I have 70 here also. If I have the element 70 here also. Say the element that what I have given is 70. I'll compare with 10. No, frequency will not be increased. Is 70 equal to 30? No. Is 70 equal to 70? Yes. Frequency count will be initially 0. It gets increased. Then 70 equal to 40? No. Is 70 equal to 70? Yes. The frequency count get increased to 2. Again, go with next element. There are no elements. The loop ends. Means we have done with the traversal. In that process of traversal, we have done an operation, that is, we found the frequency of the element. Frequency means occurrence, number of occurrence of a given element. So how we can do this? Let us see with this program. So as usual, we have the array a of 10. So as soon as the compiler encounters that array declaration, it is going to allocate the memory to store 10 elements, maximum 10 elements. Totally, say if it is 16-bit machine, say 2 bytes, 2 into 10, 20 bytes. So for example, from 101 up to 20 bytes of memory will be allocated, each 2 bytes. Okay. So a of 0 to a of 9, the memory is allocated. The memory is fixed. After I allocate the memory, then I can ask the limit for the user. So it's not that I need to use all the allocated memory. I may use some amount of the memory. That is what the drawback of array is actually. It is predefined. Once the memory is allocated, we just cannot resize it. If I use only 5 out of 10, the remaining 5 will be wasted here. That is what the main disadvantage of arrays. Now, I say a of 10. Memory is allocated. Then I have the variables I for the loop, n to accept the limit, ele the search element, and frequency, that is the count. I need to count the occurrence of the element, right? So I need to set that to 0. I am going to initialize that to 0. So frequency will be initially 0. Now, enter the limit. The first message, enter the limit. I just say I want to enter 5 elements. So I am going to accept that in n. So n is going to store that value 5. Then I say enter the elements. Enter the elements. So you all know how to accept the elements into the array. As usual, the loop starts I equal to 0, 0 less than n, condition true, store the values. I am going to enter the first value 10, store that in the address of a of I. So 0 n, so it is 0, 0 less than n means 5, yes, condition true, get inside, then accept an integer value, store in the address of a of I. So a of 0, I am going to get this 10. Then again look back, I gets increased, I becomes 1. 1 less than 5, yes, true, execute this, scan an integer, so I am going to type 30, store that in the address, say for example 103 in the address of a of I. I means how much? This is what the I value, this is what the I value, a of 1. Again look back, it is 2, I plus plus, I gets increased by 1, so it is 2. Again check the conditions, iteration and check the condition. If condition true, again execute the scanf statement, accept the value, so I just say a of 2. Then loop back, iterate, this is what iteration, I gets increased. 3 less than 5, yes, accept the next value, 3, then 4 less than 5, accept the next value, a of 4. So I have accepted 10, 30, 70, 40 and then 70. So it has been stored in the respective address. Again loop back, 5 less than 5, condition not satisfied, loop gets terminated, control to this printf statement. I'll ask for the search element, enter the search element. So search element, let me give it as 70. So that will be stored in ELE. Store that in the address of ELE. Right? Next, now the process starts. This is what the algorithm that what we wrote here. This is what the actual process we wrote in the algorithm. For I equal to 0 to n. 0 to n, that is I say 0 to n minus 1, so it is less than n I am saying, so it is n minus 1. If the condition true, then I need to process something. So this is what the processing statement I have written. If this is the processing statement to check the frequency of the element. So what I am doing here, let me start from the loop here. So I equal to 0, 0 less than n. Let me write the iterations here. So I equal to 0. So let me write the iterations to make you understand clearly. I equal to 0, 0 less than n. N means 5. Is the condition true? Yes, this is what the I value. Condition true. See, understand the flow. Based on the evaluation of this loop condition, if true, I am going to execute this if statement. If this condition evaluates as true, I am going to execute this statement, then loop back. Condition true, execute this. If this condition true, execute this and loop back. But if this condition is false, skip this and then loop back. So we'll see that flow now. So 0 less than n condition true, loop condition is true, get inside, check the if condition is a of I means how much? 0. Equals to search element means 70. What is a of 0? It is 10. Is 10 equals to 70? No. Condition not satisfied. So this statement frequency plus plus will not be executed. It is going to skip that. Then take a loop back. I gets increased. I becomes how much? I becomes 1. 1 less than 5? Yes, condition true. Again loop condition is true. Execute this immediate statement if condition. I say a of 1 equals to search element 70. A of 1 means how much? It is 30. Is 30 equal to 70? No. Again condition not satisfied. this frequency plus will not be executed. It is going to skip that. Again take a loop back. I plus plus, then I gets increased. I becomes 2. Again check the condition. 2 less than 5. Yes, condition true. Again get inside. A of I means A of 2. This is what the I value that you should know. A of 2 equals to 70. What is A of 2? It is 70. Yes, 70 equals to 70. We are using equality operator. 70 is being compared with 70. Condition true. Execute this frequency plus plus. Now the frequency counter gets increased. It was 0. 0 plus 1, it is 1. Now the frequency value is changed. See, we are doing the traversal here. That you should understand. We are visiting each and every element at least one. So we visited 10, right? Then 30, then 70. We are still in the loop. Again loop back. Frequency gets increased. Now execute this and then loop back. Now again I gets increased. I becomes how much? This is what the I value. 3 less than 5. Yes. Condition true. Get inside. A of I. A of I means A of 3 equals to search element 70. What is A of 3? It is 40. Is 40 equal to 70? No, condition not satisfied. So skip this statement. Then take a loop back. I gets increased. It becomes 4. 4 less than 5. Condition true. Now check this. A of I means A of 4 equals to 70. Search element. What is A of 4? It is 70. Is 70 equals to 70? Yes. Condition true once again. So this if condition is true. So now I need to execute this frequency. Frequency was 1. So it is 1 plus 1. Frequency becomes 2. So the frequency value is 2. Again take a loop back after increasing this frequency. Take a loop back. I becomes 5. 5 less than 5. Condition not satisfied. When this loop condition not satisfied, it will not allow you to enter into the immediate statement. It has to come out of the loop. The loop gets terminated. Loop condition is false. When the loop condition is false, I cannot execute if. If I cannot execute if, then I cannot execute this also based on this. So the loop condition is false. I need to terminate the loop. The control will be to the if condition. So by the time I think you have understood how we did the traversal from 0 to n minus 1. That is what we studied in the algorithm. I equal to 0 to n minus 1. Do some process. It can be any process. When the loop ends, that is when we reach all the array elements, stop the loop. Means array elements have been traversed completely from 0 to n minus 1 and the process is also done. Come out of the loop. Then I need to print some message, right? That the frequency of the element, or if the element does not occur also, I have to go from 0 to n minus 1, and in any case this frequency will not be increased. But now in this case, with this example, the frequency is increased, right? So control will be to this point after I terminate this. Loop terminates, control to this point. I need to check is frequency greater than 0. What is the frequency value? It is 2. Is 2 greater than 0? Yes. Condition satisfied. I should get a message. Frequency of. The message will be frequency of percentage D means ELE. 70 is percentage D means frequency it is 2. Frequency of 70 is 2. That will be my output. But just imagine I have given the search element as 100. So here I'll do the traversal of course. But here everywhere I need to say 100, 100, 100. Everywhere I need to say 100. Right? 10 equal to 100? No. Frequency will not be increased. Again 30 equal to 100. Frequency will not be increased. Again 2 means it is 70 equal to 100. Again no. Frequency will not be increased. Again A of 3 40 equals to 100. No. Again 70 equals to 100. No. Then the loop terminates. We did the traversal. We did the process also. But frequency was not increased because this condition was false. A of I, that is search element 100, could not match with any elements available in the array. So frequency, this particular statement. See, based on this if condition, this immediate statement gets executed if true. If not, it is going to skip. Then loop back. So this is what happened. In every case, the loop, we enter, we check the condition, then the frequency will not increase because the condition is false. Then loop back, then done with all the traversal, then terminate the loop, then check frequency will be 0 itself, 0 greater than 0, no, condition not satisfied, come to this else part, get a message, percentage d does not exist, that is ELE, 100 does not exist. This is what with the traversal operation. So hope you have understood with this. Try out this program and you will get the output like this. So let us see the execution of this program now. So here we have the complete program to understand this program. So we have the array A of 10, control variable I, N, ELE, frequency. We are going to accept the limit of the array. We are accepting the elements. So here we have the complete program to understand this traversal. So we are trying to find the frequency of the element. So the array declaration, we have the elements ELE, I, N, and frequency is initialized to 0 as usual. Then we accept the limit of the array. We enter the elements, search element. Then this is what the actual algorithm that what we learned. So we are going to do the traversal with this loop. In the process of traversal, we are going to perform this operation where we are trying to find the frequency. Then if the frequency gets increased, we get a message that the frequency of the element is this much. So let us save this program, run the program. So enter the limits, I'll just say 5. Enter the elements, I just say 10, say 20, say 30, say 20, then 40. Enter the search element, that is for which I need to find the frequency. I just say 20. So 20 is appearing twice in the array elements. So what will be my output? Say frequency of 20 is 2. The same way, I can also check one more set of input, run the program. Enter the limit, I just say 5. Enter the elements, I say 10, 20, 30, 40, and then 50. Enter the search element, I just say 70. So what will be the message? 70 does not exist. So this is how we do the traversal. We visit each and every array element and perform some operation. It can be any other operations also that what you can try out. So that's all for today's video. So in the next video, till then, take care. Bye-bye.